Okay, so hurricanes. Response? Yep, there's a lot of emergency response, government disaster funding, things like that. Is it well used? Not necessarily. When I was in Alabama, Tuscaloosa, we were on the edge of the effects of Hurricane Katrina. We actually still had gas, but there were trees down, power was out for a while, roof damage, things like that. So there was not nearly as bad as folks in New Orleans or coastal Mississippi, but we did have some damage. And so it was declared part of the disaster area and able to obtain funds for there. And so you had developers getting money to fix things up, and what they built was high price apartments to rent to football fans. Not what Tuscaloosa needed. They built too many high-priced apartments, more than they was interested in. But the folks really needing things are the folks needing low-priced apartments, not high-priced. So we do have some issues of regulation. Another thing, Hurricane Andrew, again, that was the first major hurricane to hit Florida in quite some time. So there had been a long time of folks doing things without hurricane. Now, of course, Florida has been hit by lots of hurricanes, so they were aware that this is a problem. Towns generally had rules saying you had to build your homes securely. Unfortunately, a lot of places were not actually enforcing. And so when Andrew came through, it was pretty obvious which buildings had actually been built up to code and thus were not damaged so much, and the ones that had been done not obeying the law. Another thing that Andrew demonstrated is thinking carefully about your whole building. What are you really concerned about for your house? Keeping you safe. Your car is not as important, so garages, especially the garage door, tend not to be as sturdy as the house itself. But if you have the same roof extending from your house over your garage, and the garage door blows in, now you've got a nice hole for the roof to have wind blowing in from underneath in the garage, and it makes it a lot easier for the wind to take the roof off the whole building than would be the case if you did not have that partial weak part under the roof. So thinking carefully about how you build, that's a significant consideration here. Besides hurricanes, you also have just plain old heavy rain. Now, tropical systems, such as hurricanes, are one major situation, but not just that. This is a picture just after Christmas 8 years ago up in South Mountain State Park, and definitely would not be a good time to try to be climbing around in the river. Of course, in general, you're not supposed to be climbing there. Not that everybody pays attention to the safety signs. But that day, we had 2.5 inches of rain, more than the stream could readily handle. And so you had quite extreme weather events from that. Some parts of the world, a relatively few large storms provide quite a lot of the annual rainfall for an area. And so things and people living there need to be adapted for that type of condition. This is an example from Puerto Rico. Back in 2003, here's your typical annual precipitation. Mountain right here. So UK has high precipitation. It's the one tropical rainforest area in the U.S. National Forest System. But you can kind of see in general, these red colors are drier. The southwest part of the island is behind the mountain range, and the winds tend to be coming this way, so tend to block the rain. Here's typically drier. But in November of 2003, there was a tropical storm system that came up from the south, and so you had very heavy rain. Of course, the UK gets heavy rain all the time, but across the southern area, normally relatively dry, you had quite heavy rainfall, a large proportion of the typical annual condition. And that's generally true for dry areas, because they are generally dry. One storm, that may be much of your annual supply. Winter weather. We'll look at extratropical cyclones in a minute, but one thing mentioned briefly before, you probably notice when it's cold, close to freezing, forecast, there's a chance there might be some winter weather, but knowing for sure. Here's an example of a forecast for Boiling Springs that I copied off the Weather Service. Wintry mix, rain, sleet, rain or freezing rain, rain or snow. There's a lot of ors in there. Again, the challenge is the exact balance of air. How much is below freezing, how much above freezing, how high or low this is in the air as to what exactly will fall. Wintertime, actually most of the year in this part of the world, what's actually falling from clouds is typically snow. Now, if there's lots of warmer air underneath, by the time that gets down to the ground, it's all rain. However, if it's close to freezing, or below freezing all the way, then snow can fall all the way down. If it's a tiny bit above freezing, maybe it will make it through without melting. If there's a little more that is above freezing, then the snow may melt and we'll have cold rain. But maybe there's a temperature inversion. We have a patch of cold air down towards the ground. As those raindrops then move into the below freezing air again, if they're below freezing for long enough, they can freeze and become sleet, frozen raindrops. Or if it's below freezing, and especially if the ground's gotten below freezing, but the air is below freezing for only a little bit, that water gets very cold, but hasn't frozen yet, and then it lands on stuff below freezing, can freeze as it lands and become frozen rain. Again, remember thinking about pressure. Sinking air, we're generally down on the ground, so we're feeling the pressure here, and we think of sinking air as being high pressure. Rising air, it's pressuring on us less, low pressure. Okay. Extratropical cyclones. Hurricanes are tropical cyclonic systems, and they can be quite impressive and damaging. I can remember Hugo. We're out of school for 2 days, and a lot of other areas had power out for much longer. Quite a mess. But extratropical, also referred to as mid-latitude cyclones, they are important weather systems as well. Extratropical, they are not powered by warm water. So, unlike our hurricanes, which can only form over warm water, these may occur anywhere and any time of the year. you can have transition between them. An extratropical system, if it moves over warm water, can become tropical. A tropical system moving over land or over cold water may become extratropical. You also have the subtropical cyclones, which show some characteristics of both, so an intermediate. Our precipitation largely comes from extratropical cyclones. Up on land, in mid-latitudes, that's our major source of storms. Winter storms, those will be extratropical cyclones. Here's a diagram contrasting the two. Tropical on the left, extratropical on the right. One thing you see, we have fronts. Extratropical cyclones are associated with a warm and a cold front meeting. Tropical, no front with that. Extratropical are powered by the temperature difference in the air to either side of these fronts. So we have warmer, again, it's relative. As long as this is warmer than the other air, it's not necessarily warm, it's just not as cold. But our warmer air here, behind the warm front, ahead of the cold front, and the colder air around is what set up the energy for our extratropical system. Again, our tropical system, it's the evaporation and then condensation of lots of water. That is our power source there. Tropical cyclones are sometimes referred to as warm core because the air in the middle of them is warmer than what's around them. Extratropical, cold core. The air in the middle is colder than the surrounding air. Also, with that warm air pushing up, we have relatively higher than normal pressure up towards the stratosphere with a low for the tropical cyclone. For extratropical, the cold air in the middle is tending to sink down. Although we've got a low at the surface, we've got sinking air up here. And so it's lower pressure than usual up at the stratosphere end of things. So we have different patterns in the two.